All right, y'all, because you did the pre-work last night or this weekend, this notes section should go really fast. So let's make sure we are ready to write some quick notes, and then we'll jump straight into practice, and you'll have more time to practice with me today, which will be awesome. So the first thing you need to do is make sure you get the notes title, 2.1 notes, AROC versus IROC. I'm going to be pronouncing AROC, AROC, and then IROC, IROC. So 2.1 notes, AROC versus IROC. And then let's really quick explore the rate of change. So y'all did a little exploration, but we're going to kind of define it, and then we'll do some more practice problems. So first, what is the rate of change? I want you to, in the box, put what you think of when you hear rate of change of a function f of x. Okay, so hopefully we got some ideas in Edpuzzle, and now I'm going to go over what rate of change is. So why do I have this picture of Fortnite, which, by the way, y'all, I am horrible at Fortnite because I cannot build to save my life. You have to build so fast in that game, and it's like impossible for me. I'm way too slow, so I just stick to Call of Duty. But this is a picture of Fortnite, and why do I have a picture of Fortnite in here? Because this mountain right here, this little mountain right here kind of reminds me of slope. You could think of mountains being called the slopes. So a visual of slope is potentially a mountain. And the definition of a slope of f of x, or sorry, the average rate of change, we're talking about average rate of change. Average rate of change is slope. So rate of change is slope. So the slope of a function f of x, we're going to say, let's make sure we define it clearly in our notes, how fast a function is increasing or decreasing. Oops, how fast a function is increasing. You could put INC for increasing or decreasing, DEC. That is the rate of change. The rate of change. Also, you should put slope. Rate of change is slope. How fast the function is increasing or decreasing. So another way to say it is slope. And then in your box or in Edpuzzle, I would like for you to tell me what are some ways that you know to write slope. There's more than one. Give me one. One way that you know to write slope. Go. Okay, so we have change in y over change in x. These are all the same, by the way. That's the same thing as saying y2 minus y1 over x2 minus x1. And then that's the same as saying rise over run. These are all the same thing, slope. They're all slope. Okay, so get those on your paper. Make sure you know those versions of slope. Now we're going to talk about the calculus version of slope. So here we go. Major concepts. Average rate of change from x equals a to x equals b. Make sure you get that down. This is like the calc version of slope. It's actually the same thing as what we just wrote up here. It's all the same, but we say it in a different way. So average rate of change is AROC. AROC, that stands for average rate of change, from A to B. Average rate of change from A to B, and then please put in your notes, these are x values. Cool. And then we're going to write an equation for average rate of change, or slope. Remind yourself, this is slope. Okay, average rate of change from x equals a to x equals b equals, and we're going to say in calculus f of b minus f of a over b minus a. All right, and then please remind yourself in your notes, a and b are x values, so like these things on the bottom are x values. And when you plug x values into an equation, like here on top, we've plugged in a and b. What do you get when you plug x values in? You get y values. So I'm going to write that. Those are y values. So make a note of that. The things on top are y values at those x values. Okay, and now we're going to get a little example graph down. Oh, but first let's make sure we understand what this is, and this will relate to what you learned in the pre-work. This average rate of change is the slope of the secant line. Slope of the secant line through the points, and I'll draw a graph, but you should write this down, through the points A, comma, f of A. So again, A is an x, f of A is a y. That's one point. And the point B, comma, and then the y value when you plug in B, f of B. All right, and let's sketch a quick graph so that we understand what the slope of the secant line is, what the average rate of change is. So here's our graph. And we have the points A, B on our x-axis. And now we're going to draw f of A, which will be right here, f of A. And then f of B, which I'm going to draw right here. Those are y values. We don't know what they are, but they're y values. And then I'm going to draw my curve going through those. So maybe this is my function. And the slope, actually, you know what? Sorry, y'all. I'm going to make this a little curvier. My bad. Hold on. Let's make this a tiny bit curvier so that we can actually like draw the slope. So I'm going to say it goes like this. Okay. Cool. And the slope of the secant line, so the slope of the secant line, I will do in green, slope of the secant line, which is the average rate of change, same thing, this equation, that is the line going through these 2 points and connecting those dots. There we go. That's the average rate of change. It's this slope. Okay. And remember, slope can also be written as m. So some of y'all might up here have written m as slope. That's another way we represented slope in the past for like an equation y equals mx plus b. That's the slope of a line. Okay, let's continue. So that's the slope of the secant. Slope of the secant is average rate of change. Now let's talk about instantaneous rate of change. So the instantaneous rate of change, let's do this in a different color. Okay. Instantaneous rate of change is the rate of change at an exact point in time. At an exact point of time. It's not the average, over a time interval. So for example, if A and B were times up here, we found the average slope over the interval A to B. Instantaneous rate of change is not the average, it's the rate of change at the exact point in time. And then this has a special name in calculus. So let's go ahead and write down that special name. Instantaneous rate of change is the same as the derivative, which is what this whole unit is about. So go ahead and write down derivative. This is a really important calculus term, and we will be talking about it more. The derivative is the instantaneous rate of change. Okay. So now let's get an example down of the instantaneous rate of change. Sorry about that. So, let's also make a note. So average rate of change was the slope of the secant line, right? Instantaneous rate of change, make a note. This is the slope of the tangent line. You need to know this. You need to know that the derivative is the slope of the tangent line. The derivative is the slope of the tangent line. It is also the instantaneous rate of change. We're just saying the same thing in like different ways. Okay, so at a point. And now let's go ahead and draw a little sketch. So say we have a graph again, and I'm going to draw my curve first just to make this easier. We have this curve, and say that we want to find the slope at an exact time, at the exact time where x equals a. This is where x equals a, right? And we want to find the slope right at that time. So that would be right here. The slope of the tangent slopes bump up against the curve. So if you want, you can write this down. bump up, the line bumps up against the outside of the curve, or the outside of the graph. So I'm going to draw that tangent line bumping up against the outside of the graph, outside, boom. That's our tangent line. And then again, the instantaneous rate of change would be this slope, the slope of that line. That would be the derivative, the slope of the line at an exact point. All right, now we're going to talk about very quickly how to estimate. How do you estimate the instantaneous rate of change? Which is the same as what? What is the instantaneous rate of change the same as? Please tell me in the box in calculus, what is the one word that represents instantaneous rate of change? Go. All right, how do we estimate the derivative? That's the word that this is the same as. At x equals a, at a specific x value. And this is how you do it. You use, and we're going to scroll up a little. You're going to use the average rate of change. You're going to use the average rate of change at two x values, at x equals a, so whatever it was asking you to estimate the derivative at that x value, and at x equals a plus 0.00001. We're always going to do 4 zeros. Notice how I do 4 zeros. And a plus 0.00001, that would be x equals a 0.00001. You're just going to add 0.00001. 4 zeros. I don't know how many I just said. Okay, so I'm going to do an example of that now. And really quick, let's write the notation of what that would look like. So you would do AROC from A to A 0.00001, which would be the same as f of A 0.00001 minus f of A over A 0.00001 minus A. And I want you to notice really quick before we move on, these sit above each other. So if you flip your x values or your y values, you may get this wrong. So just notice that the same x values and y values, they sit like the ones that are related to the x values are right above those x values. Okay, here's an example, and then we'll do some practice problems together. Find the average rate of change of the function y equals x cubed on the interval 1, 3. So 1, 3 is our a and our b, a comma b. And this is asking for average rate of change, so we're going to say average rate of change from a to b, from 1 to 3, right? From 1 to 3 equals f of b, which is 3, minus f of a, which is 1, over 3 minus 1, equals, okay, f of 3, this is the y value when you plug in 3. Don't be scared by that. So f of 3 equals, here's y. So that would be 3 cubed, I'm just plugging in 3, minus f of 1 would be 1 cubed over 3 minus 1. All right, if this was a short answer, you could leave your answer just like that. If it's multiple choice, you're going to have to simplify all the way. So let's go ahead and do that. That is 27 minus 1, which is 26, over 2, which is 13. Cool. Let's go on to another one. Now find the average rate of change of the same function on the interval 2, 4. I want you to do this one. So what number do you get when you find the average rate of change of the same function over the interval 2, 4? Go. Okay, I'm going to do it very, very quickly. So AROC, the same function as above, 2, 4, equals f of 4 minus f of 2 over 4 minus 2 equals, when I plug in 4 for my y value, I get 4 cubed minus 2 for my y value cubed over 4 minus 2 equals, that would be 64 minus 8. 64 minus 8 is 56 over 4 minus 2, which is 2. And then let's see, 28. I think that's right. If my simple math was wrong, I am sorry. Sometimes my simple math sucks. I think that's right though. All right, let's move on. So this is the last type of problem you need to know. To the nearest thousandth. To the nearest thousandth. Estimate the instantaneous rate of change of the function from question 1. Okay, so we're still using this x cubed. So y equals x cubed. Y equals x cubed is my function. And we're trying to estimate instantaneous rate of change. That's IROC. Now, cool. So this is what you need to do. You need to use AROC. So IROC at x equals 3. And then we're going to say we're estimating it. It says estimate, so it doesn't have to be perfect, but that's approximately the average rate of change. And then what did our notes say? They said do the average rate of change from A and then A 0.00001. So that's approximately the average rate of change from 3 is our A value. So A 3, comma, to 3.40 of f of b, or f of 3.00001 minus f of 3 over 3.00001 minus 3 equals, okay, you would plug in these y values. Plug in 3.0001, so we're going to say 3.00001 cubed, because we're still using y equals x cubed, minus 3 cubed over 3.00. I'm going to pretend that this is short answer, and we could leave our answer like this. That is an estimate for the derivative. So let's write that down. That is an estimate for the derivative using AROC. That's what this is. Derivative. Okay, let's do some practice.